So we are discussing about the applications of mesomeric effect. So first we are already discussed about stability of intermediates like carbocation, carbene, anion and free radicals, and now we need to discuss about the acidic strength of carboxylic acid and also phenols. Okay, then we will be discussing about basic strength of amines. Okay, so let us continue with our discussion. So we are discussing about these particular questions. I asked you to solve this question. Okay, so just give a try for this once again from your understanding. See here, so like this is a acidic nature of, I can say acidic nature of phenols here. Acidic nature of phenols we are discussing now. Okay, phenols we can write. So now here we have just simple phenol, and here phenol at para position we have nitro group, and here one alkyl group and methoxy group and one chlorine. So we know like this nitro group is electron withdrawing group and these alkyl groups are electron releasing groups. I can say nitro group is plus, I mean minus M effect, it will show minus M effect and also minus I effect. It means it will withdraw the electrons towards itself. Okay, and this alkyl group will be plus I group. Okay, and this alkyl like alkoxy group will release the electrons like this, and I can say this will be minus I group and plus M group. How I am saying this is plus I group, this is minus I group? See, carbon alkyl groups are always minus plus I groups, and there is no mesomeric effect because there is no non-bonding electron on this atom, so there is no need to discuss about mesomeric effect because it will not show mesomeric effect. Okay, only those species which is having non-bonding electrons are the conjugative positions, so that will be showing. Okay, here we have lone pair, so therefore oxygen can show mesomeric effect, that is what plus M effect it can donate. Okay, now since oxygen is more electronegative, it will withdraw the electrons using this sigma bond from this carbon, so I can say minus I group it is. Okay, these two effects are there with respect to this. Okay, now chlorine will be having this electron like non-bonding electron, so it can donate the electrons, so I can say plus M effect, but it can also show minus I effect because of its electronegativity, so I am writing minus I group. So this is how you need to decide first. Okay, I mean electron releasing group, withdrawing groups. So these are normal things we will be using. Okay, but in order to explain the acidic nature of phenol, first of all take the phenol here for understanding purpose. Let us write the phenol. Okay, this is how we will be writing the phenol. Okay, how this phenol will show its acidic nature. See, so what do we mean by acidic compound? It should liberate or it should release H plus ion. A proton should be released from this compound. So here we have one OH group now. So this is the most polar bond here which can be like releasing the H plus ion. So we can say this is a weak organic acid. All these acids are like phenols are weak organic acids, I can say. Here we are writing this arrow mark now. So since I am saying weak, we can use some reversible condition. Okay, so now it is releasing H plus ion from here and we are getting a phenoxide ion O minus, and H plus ion is released. This is what the proton, and I can say this is how the acidic nature of phenols will be explained. Okay, now the acidic nature of phenol, in order to move this equilibrium forward, this species has to be more stable, therefore equilibrium will move forward. So I can write phenols acidic nature depends or explained by phenoxide and by its phenoxide ion stability, phenoxide, it means this is a phenoxide ion stability. I will explain you very clearly, don't worry, just hold on for some time. Phenoxide ion stability. So if this phenoxide ion is more stable, this equilibrium will shift towards forward. It means it will be showing more acidic nature. H plus ion ease of release of this H plus ion will be more when it is releasing this side. So how this will be released, will move this side when phenoxide ion is more stable. So we need to check the stability of this phenoxide ion. So now in order to check the stability of phenoxide ion, just write the phenoxide ion here. So some groups should should withdraw this negative charge into the ring, therefore the compound will be getting stabilized. So I can say phenols, or I can say electron withdrawing group containing phenols. I am saying electron withdrawing group containing phenols are more acidic, okay, and electron releasing group containing phenols are less acidic. So how I am saying this? Because in order to stabilize this negative charge, so if there is a group G, if this group is electron withdrawing group, so that will withdraw this negative charge towards itself and stabilizes this complete phenoxide ion. Okay, so now out of these four options, so which is electron withdrawing group here out of these four options? So nitro group is electron withdrawing group, which is very strong electron withdrawing group, and it will increases the acidic nature of this phenol. So which is more acidic out of all these things? So 2 is more acidic here. Okay, then next after this, see all these are plus like I told you minus M plus M group and everything. So out of this, so if we compare, this is completely electron releasing group only. So out of these two, so we can go with this is having so minus M effect more. So I am saying here 5, okay, and here we can also talk about electron releasing effect by this inductive effect. That's why I am taking here. Okay, then out of the other options, see here we have no electron releasing group or electron withdrawing group, therefore I can see first option here, and out of these two options here, this is having plus M effect, which is more dominating than this plus I. So I can say here 3 and the least is 4. So this is how you need to decide the acidic nature of phenols. So acidic nature of phenols depends on phenoxide ion stability. So if electron withdrawing group is containing on this phenoxide ion, that will be more stabilized, therefore that compound will be more acidic here. Okay, I hope this is clear. So I will be giving one more option, one more question here. So let us say I have phenol connected to nitro group and phenol connected to aldehydic group. So tell me out of this which is more acidic. So we know these two groups are electron withdrawing group, but nitro group is more having more minus M effect, therefore this will be more acidic. I hope this is also very clear. Okay, then next let us move forward. Let us discuss about acidic nature of carboxylic acids. So let us say here I have benzoic acid, this is benzoic acid, and here on the same benzoic acid let us insert one electron withdrawing group. Just for generalization purpose I just wanted to write here, here it is attached to electron withdrawing group and here it is attached to electron releasing group. So like this let us generalize. So what I told you in case of phenol, same story apply here also. We need to check for the respective conjugate base stability. So how can we write conjugate base here? For example, this is a carboxylic acid if we consider. So since carboxylic acids are the weak acids, so I can write RCO, O minus here, the next H plus. So if this is acid, then this should be conjugate base of this acid. Okay, so what I told you, we need to check for the stability of conjugate base. In order to make this equilibrium to move forward, this should be more stable, therefore equilibrium favors forward. Okay, by this reason you tell me, so which carbon, like which carboxylate ion with the negative part of these acids we have to consider. So which carboxylate ion is more stabilized? The one which is having electron withdrawing group, that will be withdraws the electrons and that will be stabilized. Okay, it means we need to check for the conjugate base stability. So electron withdrawing groups increases the acidic nature of carboxylic acids. So the one carboxylic acid with electron withdrawing group respective conjugate base is more stable, therefore the respective acid will be more acidic. So like that you have to decide, and here you can write electron releasing groups decreases the acidic nature of carboxylic acids. So out of this ABC, so which option is correct, like what is the order here? We can say B is more acidic, then A, then C. So this is how you need to write the acidic nature. So let us take one generalized example, I mean some common examples here. So here I have carboxylic acid like this, and the second option will be, here I am inserting nitro group, here there is no group, and here we have some aldehyde group, and let us take one more option too. Here let us insert one, which group will take one phenol group, let us say. Okay, so these are the things are there. So otherwise we will take one alkyl like alkoxy group. So anything you can take. So let us generalize our explanation using these examples. Okay, here tell me the acidic nature order of this ABC, ABCD. Okay, so how can we decide? I told you more electron withdrawing groups increases the acidic nature of carboxylic acid. So here this is which type of group it is? Minus M group and minus I group. So there is no electron releasing or withdrawing group here, and this will be minus M group. Okay, and then next, what about this group? This is minus I, but it can show donate electrons like this, therefore we can say plus M. So while answering the questions, you have to decide what are the effects are present in that particular compound, like plus M, minus M, and hyperconjugation. All these things we need to consider. So you can consider plus M effect or mesomeric effect is dominating here. So out of this, so here it is more stabilized, the conjugate respective conjugate base is more stabilized, therefore option A will be having more acidic nature because it is strong electron withdrawing group. Then this is the first acidic compound. Then next, out of these two, this is minus M group, that is plus M, so minus M effect is more, so C I can write here. Then next, so out of this A and C, how can say, we know nitro group is strong minus M group, that's why this is more acidic, C is over. The next, out of this D and B, there is no effect here at para position, so I can write B, and this is electron releasing group, so this will decreases the acidic nature when we compare with B, so that will be the least. So this is how you need to decide the acidic nature order. Okay, I hope this is also clear. Okay, let us move forward. So here, before going to discuss that, so I just want to give you some basic idea on ortho effect. See, I have carboxylic acid like this, okay, and have one more carboxylic acid. Here I have electron releasing group, alkyl group, and one more I have here CH3. So now tell me, out of this ABC, which is more acidic? Out of this ABC, which carboxylic acid is more acidic? So we know alkyl groups are plus I groups. We can say here also these are two plus I groups. As per the above statement, we might thinking that so electron releasing groups are there, so these are less acidic than this A. But in reality, B and C is more acidic than this A, because there is something called ortho effect here in carboxylic acid case. So what is this ortho effect? Okay, so I told you while studying about resonance, I told you like resonance and equivalent resonance, means conjugation and equivalent conjugation. So when I told you equivalent conjugation, so I explained that if the conjugation is between the same atoms, for example here after removing hydrogen H plus ion, so we will be having the respective conjugate base like this, conjugate base something like this from this benzoic acid. Now see, if the conjugation is between this oxygen and this oxygen is taking place, so this type of conjugation is called equivalent conjugation. What is that? Equivalent conjugation. So I can write O minus and double bond O like this. This is what the equivalent conjugation. But if I say, see, this is what the equivalent conjugation, this is fine. Okay. Now you can also observe there is something called cross conjugation here. So instead of involving this group, this O minus, see this can be also in conjugative position with this double bond. No? See, double bond, single bond, double bond. It means that is also alternate position, which I can say conjugative system. So this kind of conjugation, instead of involving this, instead of stabilizing this negative charge, these pi electrons are disturbing the stability of this negative charge, stabilization of this negative charge, right? Therefore, I can say this is cross conjugation like this. See, this will be remains like that only, but whatever the pi electrons are there here, those are moving here, it will become like this. So this is how the cross conjugation taking place, cross conjugation. Okay. So this cross conjugation will not be much effective, and that is disturbing the stability of this carboxylate ion. Therefore, due to this cross conjugation, stability is decreasing. Okay. So now if we push this, if we push this carboxylate ion out of the plane of this benzene ring, if we keeping this carboxylate ion out of this benzene ring, so what happens, this phenyl ring, what happens, that will be having only conjugation with this oxygen, but it will not involve with this benzene pi electron. So therefore equivalent conjugation is only seen in that case, right? It means that will be more stabilized. Okay, so equivalent conjugation is more stabilized than this normal, this cross conjugation or anything. Okay, so I can say, so in order to push this, so at the adjacent position, if any bulky groups are present, so that will pushes this carboxylate group into out of the plane. Therefore it will be having only what? Equivalent conjugation only. So now the pushing will be more effective when there is bulky groups. See, here we have two bulky groups, therefore this will be pushed out of the plane more effectively when we compare with these two things, and equivalent conjugation will be more in this case for this respective conjugate base. Therefore I can say C is more acidic. C is more acidic because its respective conjugate base is stabilized by equivalent conjugation. Okay, so whatever the groups present, whether it is electron releasing group or electron withdrawing group at ortho position, if they are bulky groups, that will increases the stability of conjugate base of this carboxylate ion, and which is resulting to increase in its acidic nature. So due to the bulky groups at ortho position, carboxylic acid acidic nature will be increases. Okay, so I can write C is more acidic, then B, and least is A. So this is how you need to decide the carboxylic acid acidic nature, and this effect is called ortho effect. I hope it is also clear. Okay, let us discuss some generalized thing here. So here we have sulfonic acid like this, and this is the first one, and then next we have carboxylic acid. Okay, so out of these two, which compound is more acidic if I ask? See, acidic means this is what the H plus ion we should remove out. H plus ion, that is what the proton we have to remove. So after releasing this H plus ion, what is the respective conjugate base? Here we have, this is a conjugate base here, and here we will be having RCO minus. So now see, I told you, more the number of resonating structures, more is the stability. Now which carboxylate, which conjugate base is more stabilized here? See, it can be in conjugation with this pi bond and also with this pi bond also. It means this is stabilized more when we compare with this. So more the stability of conjugate base, more is the acidic nature of respective acid. So that's why the acidic nature of the sulfonic acid is more than this carboxylic acid. So we can go with sulfonic acid more acidic than carboxylic acid. So this is the reason for this order. Okay. Then next, always carboxylic acids are more acidic than the phenols. You can remember that. Okay, because carboxylic acids are having equivalent conjugation, which is not there in these phenoxide ions. Okay, or phenols. So this is the order here. So methanol is more acidic than the water. So except methanol, all alcohols are lesser acidic than this water. So methanol is more acidic than water, water is more acidic than these alcohols. Okay. Now we know, and when we compare alcohols and alkynes, so alcohols are more acidic. Okay. So alkynes, when we compare with amines, alkynes are more, and amine, methane, so amine is more. Okay, like ammonia is more. So this is how we need to write the order. So this order is important order, just make a note or take a screenshot of this. Okay, this will be very useful. Okay, I hope you are following the class very effectively. So this will be helpful for you. Okay, so now bond length. So we know between carbon-carbon, so generally we know in organic compounds we will be having carbon-carbon atoms more, bonds will be like this. So carbon-carbon, it may be single bond or some partial double bond character which we will be seeing in benzene ring, right? And similarly we will be having some triple bond, double bond, and also maybe sometimes triple bond also. Okay, so now which bond length is more here? We know more the bond order means number of bonds, more the bond order, lesser the bond length. So bond order inversely proportional to bond length. Okay, so bond order is 3 here, so it should be having least bond length. So bond length order will be like this. Okay, I hope this is also clear to you. Now I just want to give you one example on this thing. See, here I have two things here. So here I want the bond length of nitrogen carbon in this example 1 and example 2. Okay, consider. So I want the bond length here which is represented with X, and here it is represented with Y. So what is the order, which is more, whether X is more or Y is more, or Y is more or X is more, like that I want the correct relation here. Okay, so we know amine group having lone pair electrons on it, so that will be releasing group like this, and aldehyde group which is withdrawing group like this, right? So here also nitro group which is withdrawing group, and this will be releasing group. Okay, so now we know here nitrogen, amine, so effect will be same from here, but it is aldehyde and this is nitro. We know nitro group is having more minus M effect than this aldehyde, so it will withdraw these electrons more effectively, therefore it will be having more double bond character than this compound. Okay, which means these pi electrons will be involving in this conjugation effectively when we compare with this, therefore the double bond character of NC in this second compound will be more than this first compound. So I can say, so double bond character will be more here, so the bond length will be less in this case. So I can say Y is having less bond length than this X. So this is the order you can write. So it is having less, the minus M effect of this is more, so withdraws the electrons more effectively and creates more double bond character here when we compare with this. So more double bond character means less bond length, as they related bond length inversely proportional to bond order. So this is how we can use the applications of this, like this based on their strength, minus M effect strength or plus M effect strength. Okay, then next, yeah. So here you tell me minus M effect of amines, so basic strength of amines I want. So here we can say minus M groups increases the basic nature of amines. So why I am saying the basic nature of amines? See, amines are basic in nature because of their lone pair electrons. So these electrons will be donated to some electron deficient lone pair like hydrogen, it can accept H plus ion. So I can say this is Lewis basic nature of amines. Okay, when we are talking about the basic nature of amines, amines are basic because of its Lewis basic nature. Okay, okay. So now let us say these are aliphatic amines, and this is these are aromatic amines. See, benzene ring containing amines are aromatic amines, and this is alkyl group containing amine which is aliphatic amine. So always remember aliphatic amines are more basic than this aromatic amine. So that's why in these two example aliphatic amine is having more basic nature than aromatic amine. Okay, when it comes to both aromatic only, so here when we have electron releasing group at the down, which is connected at para position, see this is releasing group now, so this will releases the electrons into the ring. It means it is increasing the electrons or releasing the electrons towards the amine group, therefore it will easily accept the H plus. It means it will be having more basic nature when we compare with this, because there is no electron releasing group. So that's why this point is written, electron releasing groups or plus M groups increases the basic nature of amines. Okay, so now out of this A, B, I just want to add one more thing here. C, let us say NH2, and here I have aldehyde group. Now tell me, out of this A, B, C, which is more basic? Electron releasing group increases the basic nature, therefore A is more basic than B. And electron withdrawing group, this will only withdraw the electrons towards itself. There is no availability of lone pair electrons to accept the H plus in C case, because electron withdrawing group is taking these lone pairs from here, the availability is less, therefore it is less basic. So A, B, C. So this is how we need to answer here. So here, why aliphatic amines are more basic? In aliphatic amines, these electrons are purely available to accept this H plus ion, which is what we can say basic strength. But these lone pairs in aromatic are involving in conjugation. These are less available to accept the H plus. So I can say less basic when we compare with this aliphatic amines. I hope this is also very clear. So if you have any doubts regarding any of these concepts, so you can comment in the below, and you can share your feedback in the comment box. Okay, thank you for watching. So please do subscribe and follow our channel for more updates on JEE or NEET or EAP set. So whatever the exam you are preparing, so our channel will be highly helpful for you. So you can share your feedback in the comment box. Thank you for watching.